quicker than the actual design of spacetime itself. It has the capacity to keep up with its consciousness of it. As a result, it will gradually dismantle this thought, filling me with a feeling of disquiet. As of now, our night sky is quickly changing, and inside the next few decades, perhaps sooner, it could turn into something totally unrecognizable. Specialists, including Neil deGrasse Tyson, are sounding the caution, perceiving the unavoidable changes brought on by the moving of Polaris. The foundational ground behind this change is shockingly unforeseen. Polaris, generally known as the North Star, has been a solid component overhead for a long time, filling in as a fundamental point of reference for space experts, guides, and stargazers alike. However, this could soon be adjusted, impacting the manner in which we see the sky and how we study the universe. We should inspect what this change could mean for us. For numerous years, Polaris has been a guiding light for mariners and stargazers, remaining immovably situated overhead. Its reliable presence has been essential for navigation, yet this security may soon be upset. A paper from the regarded Royal Galactic Society, published in September 2023, raised concerns about the fate of this divine marker. Polaris is entering a tempestuous stage, one where it could possibly detonate, vanishing from sight forever and changing the sky as we know it. Before considering what could happen to this event, we should look more deeply into the attributes of the star itself. Polaris is particular in light of its closeness to the heavenly North Pole. Situated directly over Earth's northernmost point, it appears to be practically still overhead. It dwells in the Ursa Major star grouping, which is commonly known as the Little Dipper. Polaris shines with a moderate brilliance, resembling a yellow-white giant star that is much larger and more brilliant than our own Sunday. However, Polaris isn't simply a solitary star. It is part of a complex triple star system, consisting of Polaris A and Polaris B as a double pair, with a third star orbiting them. The gravitational forces between these stars influence their orbits and behaviors, and disturbances in their associations could cause shifts in their brilliance or throbbing patterns. In any case, the exact nature of these forces is still not entirely understood. Polaris is situated around 323.23 light-years from Earth, meaning the light we currently see from it began its journey quite a while ago. If Polaris were to detonate, we wouldn't see the effects for over 300 years. It's even possible that Polaris has already detonated, but we still haven't observed it. Since forever ago, the North Star has held significant cultural, navigational, and symbolic importance. Its constant position has made it an important guide for ancient mariners navigating across oceans and lands. Symbolically, Polaris has represented endurance and direction, staying unaltered in the ever-moving sky. For stargazers, Polaris has been a critical reference point in the study of heavenly developments and variable stars. As a Cepheid variable star, its occasional changes in brilliance have provided essential insights into the properties of stars and the behavior of variable stars. This characteristic has also been key in measuring vast distances and calibrating scientific instruments, as its throbs follow a predictable rhythm, making its behavior easier to forecast. However, Polaris has begun to show signs of deviating from its usual behavior. This anomaly in its throbbing cycle has intrigued astronomers, prompting further investigation into the cause of these surprising changes. Rather than sticking to its expected pattern, Polaris has started to show irregular darkening, which has led to concerns that the star may be approaching the end of its life cycle. This behavior aligns with what is seen in stars that are nearing their final stages. The progressive increase in the throbbing period of Polaris, once consistent, has been traced back to interactions within its star system. There has been an annual increase of around 4.5 seconds in the throbbing period. While this might seem insignificant, it carries important implications. Some astronomers suggest that gravitational forces between the stars and the Polaris system could be driving these changes in its environmental conditions, directly impacting its throbbing patterns. Others are more concerned that Polaris is entering a critical stage that could lead to an explosion. The similarities between the behavior of Polaris and that of Scorpius, another noticeable star in the Orion constellation, are striking. Both stars have shown complex variations in brilliance, raising concerns that they may be approaching an explosive end. Stars at the end of their life cycles often display such abnormalities before their demise. NASA has expressed greater concern about Scorpius, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star approaches the end of its life, it goes through several phases, including the red giant stage and ultimately a supernova explosion. Given the unpredictable throbs seen in Polaris, scientists predict that it has entered the stage of helium depletion, which is typical for giant stars approaching their end. These anomalies align with patterns seen in stars nearing the end of their life cycles. However, strong evidence of an impending supernova is still uncertain. Astronomers are continuing to track these anomalies to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a spectacular event overhead, possibly eclipsing the moon and remaining visible for days, weeks, or even months. Its brightness could dramatically alter our perspective on key constellations like the Big Dipper or Ursa Major, within which Polaris resides. Such an event would be one of the most remarkable celestial occurrences in recent human history, offering both a scientific spectacle and a deeply symbolic moment for cultures that have relied on Polaris for millennia. The change in Polaris's behavior raises numerous questions about the future of our night sky. While we may not yet know the exact timeline or nature of its potential explosion, the star's transformation provides a valuable opportunity for astronomers to observe the final stages of a massive star's life cycle in real time. The data gathered from these observations could offer insights not only into Polaris's fate, but also into the broader processes that govern stellar evolution, supernovae, and cosmic phenomena. In the meantime, as Polaris's light continues to shine, albeit in a changing pattern, it remains a beacon for those who look up at the night sky. Whether it will remain steadfast for the generations to come, or whether it will soon leave us with a new, unrecognizable celestial canvas is still uncertain. But one thing is clear: Polaris's influence on both science and culture will persist, whether it is visible or not. As we continue to explore the mysteries of the universe, the fate of the North Star serves as a reminder of the ever-changing nature of the cosmos. Just as Polaris has guided humanity through time, its eventual transformation will offer new lessons and possibly lead to an even greater understanding of the universe's vast and unpredictable nature. Polaris assumes a significant part, luckily. Earth would probably stay safe whether or not Polaris detonates, because of its size and distance from us. While the blast of Polaris could not be essentially as outwardly awesome as insect juices, it may as yet be noticeable to the unaided eye for a lengthy period, surpassing close-by stars. This would undoubtedly draw the consideration of space experts and observatories, producing far-reaching interest both in the scholar community and among stargazers. Anyway, the effect on Earth's current circumstance or biological systems would be less significant compared to a cosmic explosion closer to our planet. Yet, what will befall Polaris itself? What is its destiny after a potential cosmic explosion? First, it's critical to take note of that, while gigantic stars commonly end their lives in a cosmic explosion, this isn't logical for Polaris. When a huge star undergoes a cosmic explosion, its center breakdowns, setting off a rough shock wave that causes the star to crumble. Anyway, Polaris is not huge enough to go through such a fierce event. Rather, once it depletes its atomic fuel, it will shed its external layers and change into a white dwarf. This change won't prompt a cosmic explosion, but rather it will result in a calmer end as Polaris develops into a small, incredibly thick heavenly remainder. A white dwarf is the packed center of a low to medium mass star that has spent its nuclear atomic fuel. This remainder, albeit generally the size of Earth, will in any case have the mass of the Sun. Once this interaction happens, we will no longer notice Polaris as far as we might be concerned. By contrasting the impacts of a potential Polaris blast with those of genuine cosmic explosion occasions, we can acquire important experiences into the advancement of stars and their definitive destinies. For example, cosmic explosion occasions like SN 1987A, SN 2011 FA, and SN 2014J have provided significant information that helps us understand what could befall Polaris in the future. For instance, SN 1354 came about in the making of the Crab Cloud, a cloud of material that continues to expand and emanate energy across different frequencies, giving stargazers a rich field of study. Also, SN 1987A, which was seen in the Large Magellanic Cloud, offered fundamental insights into nucleosynthesis and the mechanics of cosmic explosion remnants, like cloud formation and the release of high-energy radiation. These disclosures can help us better grasp the novel attributes of Polaris. The formation of nebulae, like the Crab Cloud, happens when material shot out during a cosmic explosion blast interacts with surrounding interstellar gas and dust, advancing the gas with heavy components and contributing to the ongoing pattern of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical cycles and vast radiation. To make a conclusive comparison, researchers are studying the differences in the composition and speed of ejected materials between Polaris' likely blast and other observed cosmic explosion events. By analyzing light curves, spectra, and remnants from these events, they can make forecasts about the possible blast of Polaris. This examination will assist in determining if Polaris blast could prompt cloud formation or affect heavenly distributions in large ways. Another critical area of study involves the pulsational variability of stars that are moving toward the end of their life cycles. By contrasting Polaris and other cosmic explosion progenitors, cosmologists hope to gain a deeper understanding of the mechanisms behind heavenly blasts. The variety in throbs and stars moving toward death might indicate inner instability or an upcoming horrific event, offering significant clues about the processes that lead to cosmic explosion blasts. In spite of detailed observations and research, space specialists are still astounded by the anomalies in Polaris conduct. Understanding the causes behind these oddities is crucial for advancing our knowledge of heavenly development. The investigation into the factors causing Polaris' whimsical throbs requires collaboration across different scientific disciplines and the development of cutting-edge models and observational techniques. The potential loss of Polaris as a divine reference point raises essential issues for cosmic exploration. Ground-based telescopes and estimations of divine distances would require recalibration, which would affect the accuracy of grandiose estimations. The vanishing of Polaris would also disrupt navigation systems and social practices that depend on divine markers, underlining the significance of this event. The puzzling behavior of Polaris highlights the need for further investigations and focused research. Cosmologists must address the complexities surrounding its unpredictable throbs and provide significant solutions to determine the star's future. The study of Polaris' fate and the potential for its eventual transformation into a white dwarf remains a crucial aspect of understanding stellar evolution. Researchers continue to examine its pulsational anomalies, which may provide key insights into the mechanisms driving its behavior. These irregularities, along with its eventual transition from a supergiant to a white dwarf, offer valuable clues into the later stages of stellar life cycles and the fate of stars like Polaris. As technology advances and new telescopes and observational tools come online, astronomers will likely gather more data, refining our models and predictions about stars' ultimate transformations. Beyond the scientific community, the loss of Polaris as a prominent feature in the night sky would have cultural and navigational consequences. For centuries, Polaris has served as a reliable guide for navigation, especially in the northern hemisphere, where it is a key point of orientation. If Polaris were to no longer be visible, it would likely lead to a re-evaluation of navigation systems that rely on celestial markers. Modern technology, such as GPS, has somewhat diminished our reliance on the stars for navigation. But for many, the idea of a world without Polaris would evoke a sense of loss, both practically and symbolically. In terms of broader cosmic exploration, the disappearance of such an iconic star could stimulate further efforts to understand the dynamics of star systems. It might prompt researchers to develop more sophisticated models to track other similar stars and better predict their lifespans and eventual ends. Moreover, if Polaris' demise results in any unusual cosmic phenomena, such as a remnant nebula or shock waves that impact surrounding regions of the Milky Way, it would provide a unique opportunity to study the process of stellar death and the subsequent effects on the galactic environment. Ultimately, the fate of Polaris and the potential for its explosion or transformation remains an area of deep intrigue. While it is not on the immediate horizon, the ongoing study of such stars contributes significantly to our understanding of the universe. As we continue to explore the life cycles of stars and their role in shaping galaxies, we are reminded of the profound connections between the smallest phenomena in the cosmos and the larger, grander structures that they help create. The eventual transformation of Polaris into a white dwarf will likely mark the end of its time as a prominent celestial body, but its legacy, through the scientific understanding it has provided, will continue to influence the field of astrophysics for generations to come. As astronomers and scientists continue their search for answers, the mysteries surrounding Polaris and other similar stars will likely drive even more curiosity and innovation in the field of space exploration.